Good afternoon, and welcome to today's webcast on Illicit Discharge Detection and Elimination, IDDE 301, Finding and Fixing Illicit Discharges and Connections. This webcast is sponsored by EPA's Office of Wastewater Management and follows up on two previous IDDE webcasts on developing an IDDE program held in September 2006 and conducting IDDE investigations held in July 2007. Both of these webcasts are archived on EPA's Stormwater Training website. My name is John Costco with Tetra, and I will moderate today's session. Thanks for joining us today. Before we hear about today's speakers, I'd like to go over a few housekeeping items. First, if you have any technical difficulties, you can call 800-833-2812. Again, that number is 800-833-2812 and give them event ID 164674. Again, that's event ID 164674. You can also click the Help button to receive any technical support from ON24. You may also use the Ask a Question area to post any technical issues you're experiencing. Please include a telephone number where you can be reached, and we will help you troubleshoot your problem. We will have a question and answer session, actually two Q&A sessions, during today's webcast. To ask a question, simply type in your question in the text box located at the bottom of your screen. Then click on the Submit Question button. You don't need to wait until the Q&A periods to submit your questions. In fact, there are a large number of participants today, so we highly encourage you to submit your questions early. There will also be several occasions when our presenters will ask you questions. These poll questions will appear in your slide window. Please submit your answers in that same slide window by clicking the appropriate radio button and hitting Submit, not in the Ask a Question box. If you'd like to see closed captioning, just click on the closed captioning button on the left side of your screen above the Ask a Question box. At the end of the webcast, you'll be asked to complete an evaluation survey. The survey will appear in your slide window. You should click on the Enlarge Slides button to view and complete this survey. EPA offers the ability to receive certificates for those who view the live webcast. In order to receive your certificate, you need to click on the Download Certificate button to view and print it. For sites with more than one participant, the last slide in this presentation will have a URL where you can download a blank certificate that you can fill in your name for each person to the site. Remember, you must print these certificates after this webcast. They will not be mailed to you. This webcast will be archived indefinitely, so you can access it after today's live presentation. The archive webcast will be posted within a few weeks on EPA's Stormwater and NPDES Training website. As a reminder, the materials in this webcast have been reviewed by EPA staff for technical accuracy. However, the views of speakers and speakers' organizations are their own and do not necessarily reflect those of the EPA. Once more, the telephone number for any technical problems you're experiencing during the webcast is 800-833-2812 and give them event ID 164674. Now I'd like to introduce today's speakers. Bryan Rittenhouse has worked as an environmental scientist with EPA's Office of Wastewater Management in the NPDES Stormwater Program since 1997. At EPA, he developed stormwater policies and wrote construction and industrial stormwater general permits. He has also worked on training, guidance, and implementation of the stormwater program, as well as running a stormwater grants program. Prior to joining EPA, Bryan worked 10 years as an electronic engineer for the U.S. Navy, doing applied research in underwater acoustics. Bryan has degrees in physics from Temple University, environmental technology and management from New Jersey Institute of Technology. Jennifer Zielinski is a water resources engineer with experience in watershed and stormwater planning and public and policy development. At Biohabitats, she worked with public and private sector clients throughout the country on projects focusing on stormwater design and retrofitting, local stormwater and watershed program guidance, watershed planning, upland area pollution prevention assessments, better site design, and other watershed consulting areas. Jennifer is based in Biohabitats' Great Lakes Bioregional Office in Cleveland, Ohio. Before joining Biohabitats, Jennifer was a program director and watershed engineer at the Center for Watershed Protection. She co-authored a national guidance manual on retrofitting outdated and failing septic stormwater facilities. It was on the project team that developed national guidance on illicit discharge detection and elimination. Jennifer was also our keynote speaker on the other two IDDE webcasts, IDDE 201 and 101. Jennifer has a BS in Civil Engineering from Case Western Reserve University is a licensed professional engineer in Maryland. She currently serves on the board of directors of the Chesapeake Stormwater Network and the Ohio Stormwater Association. Our third speaker is Dan Christian. Dan is a director of water resources and a senior project manager for Tetra Tech's infrastructure unit in Lansing, Michigan. Dan has over 19 years of experience in water resources engineering with expertise in hydraulics, hydrology, field monitoring, stormwater management, stormwater permitting, and master plans. He's been active with illicit discharge issues since 1991 and has assisted cities, villages, townships, counties, and states with the planning, investigation, elimination, and enforcement of their illicit discharge program. Dan has a BS and MS in civil engineering from Michigan State University. And finally, Ann Wilson has been employed by the city of Alexandria, Louisiana since 1988 and has held the position of Superintendent of Environmental Services since 1994. As superintendent, Ann advises city departments on environmental issues concerning stormwater, wastewater, drinking water, sewage, sludge, hazardous waste, and solid waste. In addition to environmental compliance responsibilities, Ann manages the City of Alexandria's wastewater and drinking water laboratories. Ann has shared her knowledge in environmental assessment and compliance as a presenter at state, regional, and national conferences on stormwater compliance, pretreatment, and environmental education. Ann is a BS in food technology from Louisiana State University. Briefly, our presentation overview, Bryan will start with giving us some illicit discharge detection elimination basics. Then Jennifer will talk about tracking illicit discharges with some examples from Dan, along with removing and fixing illicit discharges. And then we'll hear a case study from Ann on controlling illicit discharges from food service facilities. So now I'll turn it over to Bryan to talk about some IDDE basics.
Hello. The first thing we'd like to show you is the IDDE guidance manual that EPA funded in a grant to the University of Alabama and the Center for Watershed Protection. This is the manual that has all the programmatic and technical how-to info to perform IDDE with, minimal, hopefully, contractor support, important to a lot of small MS4s. The URL is at the bottom there, and there's a lot of information in there that we could never possibly put in one webcast, so that is the Bible.
All right, Bryan, we're going to take a quick poll question here. So the first question here is, are you familiar with the IDDE manual that Bryan just talked about? Again, you can download a copy of that manual off of EPA's website, but we're very interested to hear how familiar the audience is with this. So click the radio button, yes, I have a copy, and I'm read it cover to cover. You're very familiar with it. The second radio button, yes, I have a copy, but have not really read it. Third radio button, you may have heard of the manual, but you don't have a copy or haven't looked at it. And the fourth radio button, if you've never, this is the first time you've ever heard of the IDDE manual. So we'll take a look here at the results. So about, a third of the people either have a copy of the manual or have a copy and haven't really read it yet. And we have about 15 to 20% of the people who have heard of it but haven't really seen a copy. So I'll turn it back to Bryan to talk about some of the resources on EPA's website.
Thank you. We do have a wealth of information on the stormwater website. Not only is the IDDE manual, the other webcasts, there's a lot of other supporting documentation for IDDE, and that URL at the bottom will take you to that site. There is also plenty of other information on the 6 minimum measures that MS4s have to comply with. So IDDE is one of the 6, and it's all there. So highly recommended you check that out. Past webcasts that John mentioned are also there. The IDDE 101 is the program development part of it, and the 201 is how to do investigations, and we're taking it from there with 301.
Yeah, Bryan, just a quick mention. These archive webcasts, you can view them online directly from your computer. You can also actually download them as a podcast onto your iPod and listen to it there. There are about 15 or 20 other stormwater and green infrastructure webcasts on that stormwater training website, too.
Okay, we have the basics of what is an illicit discharge coming up. An illicit discharge is a discharge to an MS4 or a waters of the U.S. that is not composed entirely of stormwater, except those that are discharges that have a permit or that are an allowable non-stormwater discharge, such as firefighting-related discharges. And you can see that list of such discharges at 122.26b2 in the Code of Federal Regulations. The characteristics of or that are relevant to IDDE are those listed at the bottom. So that's what we're going to be pretty much covering in this webcast. Now, a storm sewer, a municipal separate storm sewer system, is a conveyancer system that conveyances owned by a state, city, town, or other public entity. Another public entity could be a flood control authority that discharges to waters of the U.S. and is designed for collecting or conveying stormwater. And this would include ditches, swales, along with the pipes, and is not a combined sewer. It can't have sanitary sewerage going through it, because that would then move it into a separate program. And it is not part of a treatment system.
Good afternoon. This is Jennifer, and I'm going to pick up with what Bryan was just discussing, which are some IDDE basics. And part of why we wanted to cover some of these basics is because it has been a couple of years since we did the previous IDDE 101 and 201 webcasts. So we just want to make sure we're on the same page when it comes to all of this terminology. So to pick up where Bryan left off, I'm going to talk a little bit more about the characteristics that make illicit discharges unique. And there's three particular items that he mentioned, including frequency, composition, and mode of entry. So the first thing to consider is discharge frequency. The frequency of discharges into storm drains is very important because it often will drive how you investigate illicit discharges and actually track them. There's three typical frequencies associated with discharges. First, continuous discharges are those that occur most or all of the time, which makes these somewhat easier to detect than other discharges. This also means that these can produce the greatest pollutant load. Intermittent discharges occur over a shorter period of time, for instance, a few hours per day, every day, or a few days per year. Because these are infrequent, these are a little bit harder to detect, but depending on their flow type, they can still represent a fairly serious water quality problem. The final type of frequency are transitory discharges, and these occur rarely, and these usually occur in response to a singular event, such as an industrial spill or a ruptured tank or a sewer break or some other type of infrastructure failure. These types of discharges are very hard to detect with routine monitoring and tracing investigations, but under certain conditions, they can exert severe water quality problems on downstream receiving waters. Second characteristic to consider when we talk about illicit discharges is composition or flow type. And any type of illicit discharge may consist of one of these types of flow types or some combination of these flow types. The most common type of illicit discharge that we often deal with are sewage or septage flows that are produced from some type of interaction between the storm drain system and the sanitary sewer system, or perhaps a result of septic system failures. Another very common type of discharge is wash water, which can be generated from a wide variety of activities and operations. Some of the most common examples include gray water from home laundry systems, or commercial car washes, fleet washing, or commercial laundry wastewater. A third discharge flow type are liquid wastes. which can be a wide variety of flows, such as oil, paint, or processed water. And these can be come out of from commercial land uses or industrial or institutional land uses. The next three flow types, tap water, landscape irrigation flows, and groundwater flows, are not typically considered illicit discharges, although in some areas of the country, landscape irrigation has been classified by localities as an illicit discharge. The third characteristic that makes an illicit discharge unique is its mode of entry into the storm sewer system. And there's typically two modes of entry that a discharge can enter the system: direct entry or indirect entry. Direct entry means that the discharge is directly connected to the storm drain pipe through a sewage pipe, a shop drain, or some other type of pipe. Direct entry usually produces continuous or intermittent discharges. Indirect entry means that flows are generated outside of the storm drain system, but enter through the storm drain inlets or through infiltration through pipe joints. Generally, indirect modes of entry produce intermittent or transitory discharges. I just wanted to point out an example of the photo on the bottom of this slide is from, an indirect entry of an illicit discharge that I just observed out in the field last week. This is at a maintenance yard, I won't say where. This is a maintenance yard with outdoor barrel storage, and you'll note that the containment unit, the yellow unit, is propped up against the building next to the barrels as opposed to sitting underneath the barrels to capture potential overflow or spillage from those barrels. And in this case, there was spillage that was traced down to a nearby storm drain inlet. So that's just an example of potential indirect entry of an illicit discharge into the storm drain system.
They probably want to keep that unit clean, I guess.
I think so, yeah. I think it filled up with water when it rained, and they just dumped it out and didn't want to have to deal with mosquitoes in the future. Many types of illicit discharges, other than sewage, can be linked to different types of generating sites. And by a generating site, we mean a land use or a particular land area where common operations can generate certain types of discharges or have the potential to generate a higher level of pollutants than typical. Different types of land uses like residential, commercial, industrial, institutional, and municipal all can have the potential to produce unique or very specific types of illicit discharges. For instance, some common residential generating sites include more rural lots that have failing septic systems. Another common type of illicit discharge from residential generating sites include oil dumping, irrigation overflows, and swimming pool discharges. Commercial generating sites are often related to operations that take place at the commercial site, such as outdoor washing or disposal of fuel waste, fleet maintenance, repair and washing. Power lot power washing and poor dumpster management is another big one that we will often notice at commercial sites. And we'll talk about that in a little bit more detail later on today. I'm going to ask Bryan to talk a little bit about some important components associated with an illicit discharge program.
So an IDDE program basically would have these 8 components you see. The first one, audit existing resources and programs, is a desktop exercise in which you determine what you already have in place and what kind of resources are available to you. The second one, establish responsibility and authority, where you have to make sure that you basically do have the authority to do what you want to do, or if you need more ordinances, then you have to contact the other branches of government, obviously, and work with them. 3, complete the desktop assessment of illicit discharge potential. That's where you would determine if you have a lot of septic systems, industrial areas, golf courses, things where illicit discharges may be clustered and originate from. 4, develop program goals and strategies. The permit terms are 5 years, and generally you have to make progress on all your 6 minimum measures, including IDDE, over that 5-year term. And here you would probably establish your priorities for the highest priority IDDEs, that you want to take care of first and go from there. Then you get down into the nitty-gritty where you have to get out and look for your IDDs in the field, and you fix them. You have to have a preventative program to alert business owners and the populace about not doing illicit discharges, and then you certainly have to evaluate the program so you can improve it. Jennifer?
Thank you, Brian. So one key point that we really want to point out is that IDDE program development is really not a one-size-fits-all thing. So Brian just reviewed the 8 important components of an IDDE program, right? Perhaps it's the components to consider if you're developing a program, but every community is going to have to develop a unique program based on their land use, density of development, age of their system, potential for illicit discharge, and several other factors, including resources that you currently have available. So we just want to what we want to emphasize here is that one method to do this is to conduct a desktop assessment of the illicit discharge potential of your community. And this includes examining factors like a history of past discharge complaints and reports, a history of poor dry weather water quality, the density of generating sites or industrial sites within your community, density of stormwater outfalls within your community, which really can vary from one community to the next, age of development, historic sewer conversion from septic systems to sanitary sewers, aging or failing sewer infrastructure, and the density of aging septic systems, just to name a few screening factors. And based on these screening factors, you can evaluate across your community and across different sub-watersheds what the illicit discharge potential is. So here we're just trying to illustrate 3 potential types of communities where one may have minimal illicit discharge problems based on this analysis of illicit discharge potential. So a program in a community like that may be more focused on integrating illicit discharge components into a wider watershed restoration strategy or watershed protection strategy or stormwater management program. A community with clustered problems may have very targeted sampling and field assessments and education within problem areas, whereas a community that is expected to have severe illicit discharge problems may want to invest more significant resources in an illicit discharge program, set up a hotline early on, and conduct screening across the entire community, and perhaps develop a more rigorous or robust sampling approach with an expanded set of parameters to deal with a variety of land uses that you might encounter. So we wanted to also just touch briefly on some topics that we covered during the IDDE 201 webcast, which was really focused on how do you get out and confirm the potential presence of an illicit discharge. One of the first things that we really focused on was the outfall reconnaissance inventory, which is a field screening method to first locate all of the outfalls within your community, record their basic characteristics, look for physical indicators of illicit discharges, and if they're flowing, conduct some simple monitoring to try to determine if the flow that is coming out of that outfall is potentially an illicit discharge. Once you've done field screening, and you have identified outfalls that have suspect discharges, a monitoring framework will allow you to confirm the presence of an illicit discharge. So you go from identifying outfalls and seeing if they're flowing or not to actually going through and confirming whether or not that flow is an illicit discharge. And how you confirm the presence of an illicit discharge really depends on whether or not the outfall is flowing, if it's non-flowing or intermittent, or if it's an obvious discharge. So at an outfall that has an obvious discharge, such as sewage, you would immediately try to find and fix the problem. For outfalls that are flowing, some type of chemical monitoring strategies may be necessary to zero in on the type of illicit discharge that is coming out of that outfall. And this could vary depending on whether or not you're a residential land use or a commercial or industrial land use. The Illicit Discharge Manual in Chapter 12 reviews the residential flow chart, which is recommended for residential areas to use a fairly simple, straightforward field test to determine whether or not the flow coming from out of an outfall is sewage, clean water, groundwater, tap water, or wash water. Guidance is also presented for several industrial benchmarks that may be used to confirm the presence of an illicit discharge in more industrial and commercial areas. This investigation becomes a little bit more challenging when you're dealing with an intermittent or transitory discharge. For intermittent discharges, there are several things that you can do to try to capture a sample of flow, one of which is, of course, potentially camping out and spending a lot of time at the outfall until you capture it. But that's not always realistic to have staff out there 24/7 monitoring these outfalls. So we turn to other methods such as damming the outfall temporarily, doing temporary off-hours monitoring, or using something like an optical brightener monitoring approach to try to capture intermittent discharges so you can do some sampling. Once you've started to collect this data and have really advanced your program, you might want to consider building up a local chemical library or a local chemical fingerprint library, which is a database of the chemical makeup of many different flow types in the community. This will allow you in the future to really streamline your monitoring so that you have actual baselines that you can use to measure your field collected data against to determine what the potential type of discharge it is.
Great, Jennifer. Now we'll take our next poll question. And for those of you who have been on EPA webcasts before, you'll see these two poll questions are very familiar. It helps us gauge our audience both in terms of who's participating and the number of people participating. So the first question today is who is participating. We'd like to know if you're a Phase 1, Phase 2 stormwater regulated community or a state government or with the federal government, a consultant, academic, or other. So please click the appropriate radio button.
I think we're going to have mostly Phase 1 and Phase 2 municipalities on here today.
Yeah, we have a lot of municipalities signed up, which is great to see because they are the ones that are primarily implementing this program. So we'll give people another couple seconds to click on the appropriate radio button, and remember to hit the Submit Answer button as you do so. And while people are doing that, we just want to remind you about all the archived webcasts on EPA's website, including the two past IDDE webcasts. If you're new to stormwater, there is a Stormwater 101 webcast that our good friend Nika Singelis did last summer, or 2 summers ago, that gives you a good refresher of the whole stormwater program. So let's take a look at the results here. And you're right, Jennifer. Almost 2/3, it looks like, are with a participating municipality. And I would assume even some of the state and federal government respondents are probably, a regulated MS4, at least some of them there.
Well, that's good. That's who we were hoping to have join us today.
Great. So let's take a look at the next poll question here. And this poll question is actually very important because it helps us gauge the number of people in our audience. We have over 800 sites signed up, but I know many of you are listening in a conference room or another location with multiple people, so this helps us gauge the entire total audience, which we'll give you an estimate of later in the webcast. So how many people are participating in the webcast today at your location? Just me, 2 to 5 people, 6 to 10, 10 to 20, or more than 20. And again, we'll give people a minute here or half a minute to respond. And as they do that, Jennifer, we do have on the EPA Illicit Discharge Elimination website, in addition to the IDDE Manual and the supporting electronic documentation like the ORI form and that, we actually have a number of examples of a regional and state IDE guidances. For example, the Ohio guidance manual for illicit discharges, and there's a couple of guidance manuals for cities and that. So
that's an excellent point, John. We have, we're really referencing the national guidance today that was developed by University of Alabama and Center for Watershed Protection, but over the last several years, several states and even counties and regional authorities have developed very specific local illicit discharge guidance manuals. And if one is available for your community, I would strongly encourage you to refer to that manual because what we're talking about is very broad. And when you think about how different the climate is across the country and so many other factors, it's really hard with a national manual to narrow in on very specifics like the challenges of monitoring outfalls when you have rain several days a year and things like that. So really tune into your check out and reference your local manual if you have one available.
Great. Well, let's take a look at the results. And, as usual, about 60% of people are just listening in on their computer. But it looks like we have a pretty high number of people listening in small groups there. So 2 to 5% is about 30, and even, bigger groups, a couple groups, more than 20 people. So that's great to see. And, again, we'll give you a rough estimate of the total number of people watching later in the webcast. So, Jennifer, I will turn it back to you to talk about tracking illicit discharges.
Great. Thanks, John. So the next section we're going to cover in this webcast is how to focus on how to track or trace an illicit discharge back to the source. So we really just kind of sped through the basics and just talked very briefly about some field investigations. And if you want to learn more about those particular topics, I would really encourage you to reference either the manual or the past webcast. So today we really want to pick up where we left off 2 years ago in IDDE 201 and focus on, okay, we've gotten to the point where we've confirmed the presence of an illicit discharge at an outfall or within a drainage channel or within a receiving water, and so we need to trace it back to the source and remove that source of the discharge. So there's really 5 main tools that we're going to talk about today that you can use to track illicit discharges back to a source. The first, a pollution complaint hotline, really relies on reporting by vigilant citizens. The next 4 methods are field investigations, the storm drain network investigations, drainage area investigations, on-site investigations, and septic system investigations. Now, these investigations can be very time-consuming and expensive. They do require special training and staff expertise, and they may result in legal action. Also, each type of investigation handles a different type of discharge problem and also has its advantages and disadvantages. And we're going to talk about each one of these in a little bit more detail today. So first, we'll talk about a pollution complaint hotline. A pollution complaint hotline is either a telephone line or a website where citizens can easily report illicit discharges, illegal dumping, or other pollution concerns. The hotline should always be supported by prompt investigations of each complaint by trained inspectors, usually within 24 hours. Back when we developed the original IDD guidance manual, we did a survey of several Phase 1 communities from across the country to kind of gather their lessons learned from the first go-around of developing illicit discharge programs. And what we found is that many Phase 1 communities have utilized hotlines to track down intermittent and transitory discharges and really considered them to be one of their most effective tools to isolate and to identify illicit discharges. There are 6 steps to consider when thinking about establishing and maintaining some kind of pollution complaint hotline. And the first step is to define the scope of this hotline. For instance, if you already get a lot of phone calls, it may be worth setting up a hotline. Also, to think about whether or not this might benefit other programs, such as an erosion and sediment control program, a trash collection program, or some other type of program within your community. You also need to define the intent of the hotline. For instance, is this going to be simply a reporting mechanism, or if you're going to set it up as a website, is this also going to be an educational tool to reach out to citizens and educate them on illicit discharges and other pollution problems? And finally, you have to define the extent of the hotline. For instance, is this going to cover an entire community or strictly a selected geographic area, such as a main downtown area or commercial district? You also have to decide what types of discharges and problems will be covered by this hotline. Once you've defined the scope of the hotline, it's time to create a tracking and reporting system. So, for instance, we mentioned one of the things you have to decide is, do you want to set it up as a telephone line or a website? If you set up a telephone line, will you allow for callers to make anonymous phone calls, which really might help a little bit because a lot of people might fear backlash for reporting some certain types of discharges or problems. You also have to think about how you design your response method. For instance, will this be a 24-hour, 7-day-a-week phone line, and also will you have personnel on board 24 hours, 7 days a week to respond to illicit discharges, or will you have limited hours during the day where you will be able to send personnel out? You also have to think about who will respond. Is it a single department, such as Public Works or an Environmental Services department, or will you also involve a health department or a fire department? Third step is to train personnel. And this involves personnel who are involved in answering phones or dealing with the website, but then also personnel who are involved in dealing with and following up on investigations. So everyone who is involved should be trained on the basics and importance of illicit discharges. We shouldn't assume that all of our staff and colleagues do know or understand what an illicit discharge is. Also, all staff involved should be trained on the complaint hotline reporting system, as well as the investigation and the tracking process. Also, for people who are going to be actually answering the calls, just training folks on good customer service is something to consider. And also make sure that everyone is aware of the expected responsibilities of all involved departments and agencies. The fourth step is to be sure to advertise the hotline, and not just to advertise it when it's first launched, but to continuously advertise the hotline so that the phone number stays fresh in people's minds. One thing that we found from talking to several Phase 1 communities across the country is that there's often a peak in reporting after a major advertising campaign for their hotlines. Also consider publicizing success stories so that people know that the hotline actually does work and is accomplishing something. The fifth step, and a very important one when we talk about pollution complaint hotlines, is to actually respond to complaints. So sending an investigator to follow up on the complaints in a timely manner, but then also to perhaps provide some type of system for the citizens who called in to report the discharge initially to follow up to find out if the problem was taken care of. And the last step is to set up some type of tracking database to track incidents as well as response times and how the problems were dealt with. This will allow you to refine your system in the future. There are many benefits associated with pollution complaint hotlines, including increasing the early detection and correction of illicit discharges, encouraging public stewardship, and also increasing the likelihood of identifying intermittent as well as transitory discharges. But we also recognize there are many challenges associated with these. It can require a lot of time and money, especially if we talk about a 24-hour, 7-day-a-week hotline and response. There is marketing required to make sure that citizens know about these hotlines. And then also there can be the challenge of establishing some type of interdepartmental process to respond to and follow up and inspect on different types of illicit discharges. So with that, I'd like to turn it over to Dan to talk to us about a few different case studies that he's dealt with that originated from calls to pollution control hotlines.
Thanks, Jennifer. Yeah, I wanted to highlight two different examples that we responded to. The first one is one that we got a call saying that there was a green substance in a parking lot of a strip mall that somebody was concerned about. The strip mall wasn't too far away from our office, so we zipped over and investigated it. And it was pretty easy to see the source of it. It tracked it right up to a restaurant in the local area. We knocked on the door and talked to a few staff at the restaurant trying to find out what was going on, and it turns out, in this case, the restaurant had recently washed the outside of their building, and using a power washer with a liquid detergent, they had left a significant amount of detergent on the pavement, which was running out into the parking lot in the catch basin. We followed up by reporting this to the municipality, who in turn coordinated with the restaurant explaining the problem and that they need to not do this in the future, and I'm happy to say that there have been no problems with the facility since. The next example is a little different. A farmer responded or complained that there was a discharge in an open drain that was making some waterfowl that he was raising as livestock sick. Due to the nature of the complaint, we went out on site and met a hazmat team on site and noted the discharge material in the drain. This is an open drainage system. We were able to track the complaint, the substance upstream, all the way to where it became an enclosed system. We continue tracking it through an enclosed system by popping manhole covers and looking in catch basins, and we're finally able to determine the source of the location. Turned out it was a location with an ice skating rink, although the ice skating rink is just happened to be there. And again, we knocked on a few doors and were talking with people on what was going on. And what we learned was that a gentleman had broken open some transformers in an effort to reclaim the copper core out of the transformer to sell for scrap metal. And in the process of doing so, he was dumping the oil out of the transformer down into the catch basin. It was very evident once you got to the source, you could see the oil slick around the catch basin draining right into it. Now, we did test the oil for the presence of PCBs, and the good news is it tested negative. The bad news is there was a heck of a mess to clean up from the oil dumping. We did further assist by going downstream using our investigation techniques to determine the extent to how far down the oil spread. The farmer did lose a significant amount of his livestock, the waterfowl, due to the oil. We did notify the State Department of Environmental Quality as well as the Health Department early on in the process, and we're really working in parallel with them. The State Department provided the enforcement mechanism for the cleanup and the fines, and I think one of the lessons learned that I wanted to highlight through both of these case studies is the importance of talking with people to find out what's going on. And with that, I'll turn it back over to Jennifer.
And actually, we'll do another poll question now. So this question is, does your community have a pollution complaint hotline that Jennifer just talked about? So yes, you have a dedicated hotline as a first radio button. Yes, but the hotline is part of a more general community concerns hotline. The third button says no, but a hotline is under development. Fourth is no. Any calls from citizens to the community regarding a discharge or dumping are eventually routed to the right staff or department. And no, we haven't even thought about this. So please click the appropriate radio button. And as we wait for a couple seconds here, Jennifer, for people to respond, I think it's good to note that for a pollution control hotline, it's also important to do a lot of education.
Absolutely.
And one good source of a lot of good education materials, EPA's non-point source program has put together the non-point source outreach toolbox. And if you go to EPA's website and just Google or search for non-point source toolbox, that'll come up. There's a lot of good examples of different outreach materials. So let's take a look here and see what the results are. And about a third of the people say they do have a dedicated stormwater hotline, with about 28% saying they use a more general hotline. And about another third say either they don't have anything dedicated, the calls are eventually routed to the right person. So that is actually a phase 2 requirement to have some type of not necessarily dedicated, but some type of a hotline to receive these public calls. So Jennifer, we'll turn it back to you to talk about the storm drain network.
Great. So now we're going to talk a little bit about the second tool for tracking illicit discharges to a source, which are storm drain network investigations. And this is probably one of the most commonly used investigations for tracking illicit discharges to a source. And the goal here is to do progressive sampling or investigations at manholes within a storm drain network so that eventually the source of the discharge is isolated to a single pipe segment between two manholes. There's two key decisions that need to be made when conducting storm drain network investigations. The first is how and where to start sampling within the storm drain network. And the second is what type of indicators will be used to determine whether or not a manhole is considered clean or dirty, as in has an illicit discharge flowing through it. So first we'll talk a little bit about the methods for how you decide where to start sampling. There's really three ways to explore the storm drain network. You can move up the stormwater system starting at an outfall or a discharge point and progressively work your way up the system. You can split the trunk and test manholes at strategic locations throughout the system, or you can progressively work your way down through the system. And the decision to move up the trunk, split the system, or move down the trunk really depends on the nature and the land use of the contributing drainage area. Typically, moving up the trunk can begin immediately when an illicit discharge is detected at an outfall, but this will require a map of the storm drain system. Splitting the trunk and moving down the system does require a little bit more preparation to analyze your maps and to determine where the most strategic locations are to investigate and sample manholes. So here's an example of an investigation that moves up the trunk. So moving up the trunk are really most effective for illicit discharge problems in a fairly small drainage area, typically when the diameter of the outfall pipe is 36 inches or less. Field crews will start with their investigations at the outfall where they have observed some type of an illicit discharge, and they'll progressively move up the network inspecting manholes until eventually indicators reveal that the discharge is no longer present. So at that point, they would have then narrowed the source of the discharge to a section of a pipe between two manholes. At that point, you would then move on to another type of investigation, such as an on-site investigation, to trace it back to the actual building or the source of the discharge. And we'll talk about those on-site investigations in about half an hour or so. The second option for splitting up the network is to be a little bit more strategic about where you do your monitoring or your investigations at different manholes. And this is typically used when the drainage area is larger or the network is more complex. In this case, field crews will select strategic manholes at different junctions in the system where they might be able to isolate discharges. This helps because it limits the total number of manholes that you would need to inspect, and also helps you to avoid locations where access and traffic might be problematic. So here's an example of an investigation where the storm drain network is split. So to do this, you start first by reviewing a map of the storm drain network that leads to the suspect outfall. Then you identify the major contributing branches to the main trunk. So in this example, the trunk is the sewer line that runs right down the center of the graphic. And then the different branches are coming in. There's one on the left and three branches that are coming in on the right. So the manholes that have been identified to be sampled in this case is the manhole at the juncture of each branch coming into the trunk, as well as a manhole the first manhole on the trunk immediately upstream of that juncture. That way, that will allow you to either confirm that the discharge is coming from the branch coming into the trunk or the branch coming into that trunk is a clean source. Eventually, you'll keep moving your way up until you isolate the discharge to, again, a single segment of the storm sewer between two manholes. And just like with moving up the trunk, at that point you may move to another investigative method like an on-site investigation to trace the discharge back to a particular building or facility. The third option is to move down the network. In this case, crews will start by inspecting manholes at basically the headwaters of the storm drain network and progressively move down the pipe system. This approach really works best in very large drainage areas that have many potential continuous or intermittent discharges. Basically, they'll start at the upstream end and then certify that they move down that each upstream branch of the storm drain network has no contributing discharges before continuing to move downstream. This can be a very time-intensive and staff-intensive and fairly expensive approach to investigating the network. However, when we did our survey of Phase 1 communities a few years ago, we found that larger communities like Boston that had chronic illicit discharge problems found this to be a fairly effective way to deal with those chronic and continuous illicit discharges. The second key decision to make regarding storm drain investigations is what type of indicators will be used to determine if a manhole is clean or dirty. The two primary methods to do this. One is visual observation, and the second is indicator sampling. Now, in both methods, field crews must first open the manhole to determine whether or not a flow is present within the manhole. Then the manhole inspections do require a crew of 2 people and should be conducted during dry weather conditions. And that's one thing to note, really all of these investigations should be conducted during dry weather conditions because we are looking for illicit discharges, which are flows not associated with stormwater runoff. Visual observations at a manhole are used to observe conditions in the manhole and look for any signs of sewage or dry weather flow. They work best really for obvious illicit discharges that are not masked by groundwater, stormwater runoff, or other clean discharges. And typically, crews progressively inspect manholes in the storm drain network to look for contaminated flows. And some of the key visual observations that are made at each manhole include the presence of flow, the color of flow, odor, presence of floatable materials, and any deposits or stains. This is often fairly challenging with working within manholes, especially when the storm drain inverts are fairly deep because it gets pretty dark. So a lot of crews might want to use fairly strong flashlights or lights as well as mirrors to be able to look down into a manhole to see whether or not the flow is present or whether or not there's any other type of indicator of an illicit discharge. If dry weather flow is observed in the manhole, then the field crew can collect a sample from that manhole and then analyze that sample in the field using probes or some other type of test to get fairly quick results to determine if the flow is clean or potentially an illicit discharge. A fairly common indicator parameter that some communities use is ammonia, although there are a lot of different types of indicators that can be used, and more guidance on that is provided in the Illicit Discharge Manual, and we also cover that in quite a bit of detail during the IDDE 201 webcast. One special or unique situation when we're talking about doing storm drain network investigations is how do we deal with intermittent discharges. Isolating intermittent discharges can be a very challenging task, but there are 4 typical approaches that some communities have used with some success to try to isolate those intermittent discharges so that you can capture enough flow to get a sample to do testing or to use visual observations to determine if it is indeed an illicit discharge. First method is sandbagging, where you place sandbags or some other type of barrier, such as a beach ball. That's the word I was looking for. Where you might place a beach ball within the system to temporarily dam up the system to try to capture flow. A couple of things to consider: we generally don't like to leave sandbags in place for very long, perhaps no more than 48 hours, and they should only be installed when dry weather is in the forecast. They should not be left in place during a heavy rainstorm because they can cause a blockage, might be washed downstream and lost, and would then require that you start the process over. But sandbags are typically installed at junctions within the network to eliminate any contributing branches from further consideration. If flow collects behind it, then we would do some type of sampling to determine if that is actually an illicit discharge. A second method for trying to isolate intermittent discharges are the use of optical brightener monitoring traps. And optical brighteners are the fluorescent white dyes that are added to some laundry soaps and detergents to whiten and brighten clothes. And their presence within an illicit discharge can indicate the presence of wash water or potentially sewage within a flow. There's some communities have used OBMs, optical brightener monitoring approaches, with success. Other communities have not found them to be too successful. We've really seemed to have heard a lot of mixed reviews about the use of OBMs. But basically, an OBM trap can be fabricated or installed fairly easily. They all involve the use of an absorbent unbleached cotton pad or fabric swatch and some type of holding or an anchoring device. And then this device with this cotton pad or fabric swatch is placed within the targeted area within the storm sewer for a period of perhaps 24 to 48 hours so that you might be able to capture that intermittent flow. Once they're pulled out of the system, we take them into a dark room and we place them under a fluorescent light, and that'll help us determine whether or not they have been exposed to some type of brighteners or detergents. When we did the illicit discharge manual, some of the research we found was that they would pick up really only the most contaminated discharges, and that sometimes the detergent level needed to produce a hit was roughly similar to pure wash water from a washing machine. And oftentimes when we're dealing with illicit discharges, we're dealing with a mix of different types of discharges and sources. So many times wash water will have been diluted by groundwater or tap water or some other type of source. So really OBMs, again, they've been used successfully by some communities, but they can present some challenges. A third method for isolating intermittent discharges are the use of automatic samplers, which trigger during dry weather flows to collect a sample. Many communities have put these in place. They can be expensive. However, they are good for very complex drainage systems and where you expect to have very severe intermittent discharge problems. Basically, again, they will trigger during dry weather flows, collect a sample, and then alert you to where this where this water quality problem is, and it can follow up with some type of field investigation. And then the last method for tracking isolating intermittent discharges is simply the use of observation of either visual or smell or other types of obvious indicators. A little bit more challenging when you talk about dealing within the manhole or within the storm drain than at an outfall. But some common things that we look for are either staining, cracked or damaged concrete or rock, or the presence of vegetation. So basically a lot of discharges might leave deposits or stains, and that is what we're looking for when we talk about looking for observing storm drain or outfall conditions. So with that, I'm going to go ahead and turn it back over to Dan to talk about a few more case studies.
Thanks, Jennifer. The observations I don't think can be emphasized enough. That's how we find many of our problems. Some of the other tracers that we find most prevalently used are the pathogens, specifically E. coli, and the detergents or surfactants. These examples I'm going to show you now were all found by tracking from the downstream outfall upstream through the system to the specific source. This first one is probably the most common thing that we find. This is an individual residential connection. In this particular case, this house was built in 1970. The sanitary sewer system from the house was actually tied to an agricultural farm tile, and the farm tile was then tied to the storm drain. And so we found this by tracking through the storm drain system and then ultimately up to the house. The next example, this is also one that would fall under the complaint reporting category of things. But again, we started at the downstream end of a storm sewer system, looking at a source that somebody had complained about, following the system upstream through the municipal storm drainage system. We popped a manhole, this manhole here, and this is a storm manhole with a sanitary sewer line that goes right through the manhole. And it turns out that the sanitary sewer line, somebody had broken the side of it, and in the course of discussions with the local municipality, we actually believed that a maintenance worker had broken the side of the sanitary sewer in an effort to relieve the sanitary system, which was experiencing some infiltration and inflow problems. I'm happy to report that this problem was very quickly fixed by the city manager once it was brought to their attention. This next example, again, we were walking open drains, in this case looking for outfalls, and we found an open drain that was leaking out what appeared to be sanitary sewage. We followed that drain upstream and identified the source as being a sanitary sewer overflow. This happened to be a sanitary interceptor that was blocked somewhere downstream, and the sewage was literally coming up through the catch basin, spilling out, and forming a channel downstream to the nearby river. What we found interesting is this should have been a hotline complaint, but it wasn't. And that this problem had been going on for so long that people had actually built bridges across the sanitary sewage creek in order to get from one side to the other. In fact, in a picture that, in looking at Google Earth, it's a little hard to see here, but you can actually pick out a sewage lagoon from Google Earth that had been formed based on how long this problem had been going on. Again, I'm happy to report that maintenance crews fixed the problem and it has been resolved. This next case, this one's a little different. Our tracer in this case happened to be ammonia. The ammonia level at the outfall and tracking upstream was off the chart. We tracked this problem up to a home center that was selling manure and topsoil and other sources outside in a covered area, but the cover was more for the sun's shade as opposed to a hard impervious surface protecting against rainfall. So rainwater was getting in, and the spillage from open bags was leaking across the pavement into the catch basins, and so we were having very high hits of ammonia from this source. And again, the municipality was able to work with the property owner to help resolve this. The last one is a little different again. This one dealt more with the oils and greases, which can be very apparent in the visual observations. Here we tracked a grease source up to a catch basin in a parking lot of a local grocery store. This grocery store has a bakery and deli that was taking their grease out back into an official grease dumpster and putting it in that. However, the grease dumpster was overflowing. The secondary containment was completely filled and was spilling over, and the grease was running across the parking lot into the catch basin. I don't know how long this had been going on, but it seems to me somebody should have recognized that there was a problem and the dumpster needed to be cleaned out. And I think this, again, points to the importance of education. And with that, I'd like to turn it back to John.
Great. Thanks, Dan. Well, we do have time for a couple of questions now. So the first question comes from Christy, who asks, can you discuss whether typical residential discharges, such as tap water from garden hoses, pool water, basement sump water, are considered illicit discharges? You want to take this, Bryan?
Yeah. Basically, if it's not stormwater, there's a good chance it shouldn't be in the system. There are those kind of discharges that are known as allowable non-stormwater discharges, of which we mentioned firefighting flows were. Often uncontaminated groundwater could be an allowable non-stormwater discharge, meaning it can go into the storm system. But that's a big if. If it's pump water, it could, have picked up oil and who knows what else. So that's liable to be on a case-by-case basis, but I would be very wary about just putting, sump water down a storm drain. Tap water, well, it does have chlorine, and you generally cannot put chlorine. I mean, POTWs and everything have to have dechlorinate the water before they can discharge it. So tap water can be an illicit discharge if it's probably in a big enough quantity, but we, as the EPA, generally don't go after citizens as violators of the Clean Water Act. That is pretty much what the function of the MS4 permit does. Is so they should be the MS4 should be the one in their public education where they would make it clear that these kind of discharges, whether it's car washing or whatever, are not allowed to be, should not be entered into the storm drain system. So basically, if you stick to stormwater being the discharge, you'll be a lot safer.
Yeah, and this is really something that should be addressed fairly early on in the development of an illicit discharge program, actually during the ordinance development stage. We provide some guidance in the illicit discharge manual on how you develop that ordinance and how you define what is an illicit discharge. And we have a whole list here of items here that kind of come up as questions in every webcast of are they not illicit discharges? And as Bryan stated, it really has to be a local decision that's made. And oftentimes it's a decision that may have been made for the locality at the state level. So again, if you have a state or a regional illicit discharge manual, I'd encourage you to check that and see what it says regarding defining different types of discharges as illicit discharges.
All right. Let's see. The next question, I'll give it to Dan. Wendy asks, how do you propose to conduct illicit discharge investigations if you don't have authority to move off your property? As an example, Department of Transportation that doesn't have the authority to investigate off their right-of-way. However, that discharge is entering from off their right-of-way. How do they address something like that?
Well, my experience in working with State Department of Transportation is they tend to follow the illicit discharge up as far upstream as you can. In many cases, and then what we need to do is work with the adjacent municipality or whomever has the authority in that area. In many cases, those are the Phase 2 or Phase 1 communities, and so they have a permit, and then it becomes a matter of transferring the obligation over to the other permit holder. And in other cases, it can be a direct property owner, in which case many of the DOTs have a tap-in permit process, which regulates the what is allowed to come into the discharge. Sometimes you need to work with the state environmental department to transfer the enforcement authority to that agency as well. My experience has been, in most cases, people will take care of the problems once it's brought to their attention. There's always going to be an exception to that, but most people are willing to work with you.
Great. Thanks, Dan. I'm going to keep us on track and turn it back to Jennifer to talk about drainage area investigations. We'll have another Q&A session later in the webcast.
Okay, so we'll keep right on going. The third tool for tracking illicit discharges to a source is what we call a drainage area investigation, which is simply a survey or analysis of the drainage area to the problem outfall to see if you can, through either rapid windshield survey or some kind of desktop map evaluation, figure out what the potential source of that discharge is. And I guess the third thing I would add on to that now, after seeing one of Dan's examples is Google Earth and looking for things like sewage lagoons and other sources over Google Earth. A rapid drive-by survey or rapid windshield survey works really well in small drainage areas, particularly if field crews are already familiar with the local business operations or industrial operations within that area. In this case, field crews will try to match the characteristics of the discharge that they have observed at an outfall to the most likely type of generating site. And then they will inspect all of those types of generating sites within that small drainage area until they actually find the culprit. We have an example here in these photos where a very thick, sudsy, and fragrant discharge was noted at a small outfall, which appeared to consist of wash water. So the field crews climbed out of the stream and did a rapid windshield survey and found a nearby commercial laundromat, which did happen to be the culprit in this case. In larger or more complex drainage areas, GIS data mapping or land use mapping can be analyzed to try to identify the potential generating areas and potentially pinpoint the source of the discharge. If only general land use data exists, maps can at least highlight suspected industrial discharges. Also, something to consider as a resource are the local, what used to be called SIC codes, but also are now called NAICS codes, which are a standard industrial classification code, to filter through that information to try to track down particular types of generating sources or activities that might be contributing certain types of illicit discharges. So with that, I'll ask Dan to talk about a couple of more case studies.
Thanks, Jennifer. These case studies are ones that we did rapid investigations because we noticed something at the outfall that said, hey, there's a problem here. Typically, these involve some kind of a strong odor or other visual observations, or maybe it's something like soap suds, like in Jennifer's previous example, which in fact was the case in this first one. This was a mostly open channel system, some enclosed. We noticed soap suds at the downstream end, and we did that rapid assessment, going upstream, popping a few manholes as we go, doing a windshield survey, and we very quickly came to an apartment building which has the laundry facility on the first floor, and the laundry facility is discharging directly out through the side of the building, through the PVC pipe you can see on the wall, going across the grass and going into a beehive catch basin just a few feet away. So here's an example of where that rapid test look at things, really helped pay off very quickly. Our next example highlights a little different method of doing rapid detection. This is a method of using canine scent tracking. Now, Sable is the dog there next to the handler, and Sable is specifically trained to find human sewage and detergents. And the whole premise behind canine scent tracking is we find our human visual and odor observations are very highly used in the tracking of illicit discharges. So if humans can do it, why can't dogs do it? And in fact, they can, and they in fact do it better than we do. It works remarkably well. In this case, at the outfall, Sable said that there was a problem. He sat up and barked and said, hey, there is a problem here. But the humans doing the investigation questioned that. They didn't think anything was the problem. However, having trust in Sable was important, and they used the dog and went upstream, and by following the system upstream, looking at the beehive catch basins in the system going through a residential neighborhood, Sable was able to very quickly pinpoint two beehive catch basins that the problem was between. And one of the interesting things to note here is that as we went upstream, the concentration, in this case of detergent, became stronger, and the farther upstream we went, the more prevalent it was and easily recognizable for the people. So again, the dog was able to identify it at a very low concentration at the downstream end, and have people follow them right upstream to the source. We identified this as being a residential laundry connection. Individual had their laundry facility in the basement tied in to the sump pump, which was discharging right out to the catch basin, and very easily tracked this down. Another example involving the soap detergents was, again, noting soap suds at the outfall point and following it upstream, doing that rapid assessment, typically through a windshield survey. We found numerous cases, and in this case, car washing activities. Car washing activities could include individual residential individuals washing cars. It can be sometimes the commercial car washes have their catch basins clogged at the outlet of the car wash, and the wash water runs down to the gutter pan and into the catch basin. And in one case, we found a automotive repair shop that was washing cars prior to giving them back to the owners, and they were doing it out on the parking lot, and again, that wash water running out to the catch basins and down. The last example I want to share with you on this subject involves concrete washout. Here we noticed at the outfall pipe that you can see on the right-hand side, this white slurry of material coming out the outfall pipe. And again, when we see something like this that's so prevalent and easy to recognize that there's a problem, immediately hop upstream and start walking around the drainage area looking for the problem. And in this case was tracked down to a nearby construction site where the concrete trucks had just been washing out the trucks and discharging the concrete wash water out directly to the receiving stream. And with that, I'll turn it back to Jennifer.
Great, thanks, Dan. So now we're going to move on to the fourth tool for tracking an illicit discharge to a source, which is an on-site investigation. And we've made reference to this a couple of times already during the webcast today, but this is an on-site investigation is used to pinpoint the exact source or connection producing a discharge within a storm drain network. And there's three basic approaches for on-site investigations. We can use dye testing, we can use video testing, or we can use smoke testing. So the first one I wanted to talk about briefly is dye testing, which can be an excellent indicator of illicit connections. It's conducted by introducing a non-toxic dye into some type of a plumbing fixture within a building, such as a toilet, a sink, or a shop drain, and then going outside of the building to a nearby manhole to look for that dye within the storm drain rather than the sanitary sewer. The presence of that dye within the storm drain will conclusively determine that an illicit connection does exist. Dye testing is most effective when the discharge is limited to a very small drainage area, say less than 10 properties. You don't really want to have to go in and do dye testing on 30 or 40 or 100 properties. We really want to try to limit this to a smaller number of properties. It's more effective when it's caused by a connection from an individual property or from a commercial or an industrial land use. The second investigative method that we use is video testing. Video testing involves guiding some type of a mobile video camera through a storm drain pipe to locate an actual connection producing an illicit discharge. And it can also show flows or leaks or damage cracks within a storm drain pipe that may allow for an illicit discharge to enter the system. This is really most useful when access to the properties is constrained and you can't really get in there with a lot of equipment, such as in residential neighborhoods, when you have a continuous discharge, and also when you're limited to a single pipe segment. However, video testing can be fairly expensive, especially if your community does not already own and use your own equipment for sewer inspections. Also, this technique will not detect all types of discharges, particularly when the illicit connection is not flowing when you're doing the actual video survey. And then the third investigative technique that I wanted to talk about briefly is smoke testing. Smoke testing involves introducing smoke into the storm drain system and observing where the smoke surfaces. Use of smoke testing to detect illicit discharges is a fairly new application. It's been used over the last several years and kind of later in the tenure of several Phase 1 programs with their initial permits. But many communities have been using it historically to check for infiltration and inflow within their sanitary sewer network, so it's not necessarily a new technique to many local public works or service departments. It can find improper connections or damage to the storm drain system. And this technique really works best when the discharge is confined to the upper reaches of the storm drain network, so again, a fairly small area, where pipe diameters are too small for video testing, and where it may be too challenging to gain access to multiple properties to do dye testing. So moving on to septic system investigations, which is our fifth and last tool for tracking illicit discharges to a source. I accidentally jumped ahead on a slide here. So illicit discharge investigations are used mostly in rural or lower density residential watersheds or in watersheds that lack sanitary sewer service and where stormwater is conveyed through ditches or swales rather than enclosed pipes. As a result, many illicit discharges can enter the stream or receiving water as an indirect discharge through surface breakouts of septic fields or through straight pipe discharges from bypassed septic systems. And there's two basic approaches that we would use to conduct these septic system investigations, including on-site septic system investigations and some type of infrared imagery. There's a lot of words on this slide. I apologize for this, but I'll try to highlight some of the important points. When we talk about on-site septic system investigations, there's usually three different types of methods or investigations that we can use at an individual property. The first is a homeowner survey, which is basically just a brief interview with a property owner to determine the potential for either current or future failure of the septic system. And this is often done in conjunction with our second method, which is a surface conditions analysis. This survey asks some fairly straightforward basic questions about their septic systems, including how many people live in the house, what's the current tank capacity, do drains in the house empty slowly or not at all, when was the last time the system was inspected or maintained. Perhaps a good question would be to ask, do you even know if you have a septic system on your property, because I suspect that there's a lot of people out there who can't even answer that question. It also asks, does sewage back up into the house through drain lines, and also are there any wet or smelly spots within the yard? Surface conditions analysis is a fairly rapid site assessment that looks for obvious indicators of failure of the septic system, like foul odors, wet and spongy ground, algal growth in nearby ditches, and also things like, are there vehicles parked on top of the drain field that might be causing problems? The third method is a much more detailed system inspection, which really should be performed by a certified professional. And this takes a look at the structural integrity of the system, maintenance records, and does a sketch of the system, evaluates distance to the groundwater or surface water, and helps to determine the potential for failure of that system. Another way another method that many communities are using to conduct septic system investigations are infrared imagery. And I'm not going to get into a whole lot of detail on this because this is a fairly complicated topic. And again, there's more guidance about this in the IDDE Manual, but then there's also been several papers published online about the use of infrared imagery. So basically, infrared imagery is just a special type of photography with gray or color scales that represent differences in temperature or moisture of objects within the image, and therefore can be used to locate sewage discharges. Infrared thermography uses a temperature difference, so in this case the temperature difference of sewage, as a marker to detect illicit discharges. And color infrared aerial photography looks for changes in plant growth and differences in soil moisture to determine the presence of standing water, for instance, from a failed septic system. With that, I'll go ahead and ask Dan to talk to us a little bit about some different septic system cases he's worked on.
Thanks, Jennifer. You know, it's just absolutely amazing the things you find out there when you start looking. In this case, we were looking at a drainage system, open channel system, tracking through a single-family residential on large parcels, so they're on septic systems. And we came across this one that we tracked back to the house. In this particular case, the owner of the house was renting the house out, and the renter, it turns out, had rerouted the pump station. So in the pump station, the grinder pump station that goes to the septic system, instead of pumping up to the field, was now pumping out to the receiving stream. We don't know why he rerouted it. The septic field was in good operational order, according to the health department. And once the property owner became aware of the problem, he took care of fixing it right away. The second example I'll highlight has to do with what we might call a temporary septic system. In this case, this is a brand new development that was going in, and the sanitary sewer connection for the development was not completed yet. It was planned to be there, so there were no official septic fields installed. This was planned to be a direct connect to the sanitary sewer. People were moving into the house, so what the developer decided to do was install these temporary septic systems, if you will. Now, the temporary septic system that he put in was nothing more than a 4-inch HDPE pipe run way out to the back near the receiving stream. He dug a ditch and a trench out to the receiving stream, so it's really not much of a septic system. This one, when the developer was confronted with the problem, he quickly finished up the sanitary sewer system and made the proper connections. Again, I think this just highlights the need for education in this program. So with that, I'll turn it back over to Jennifer and John.
Great. Thanks, Dan. So now we're going to move into the third segment of our webcast, which focuses on removing and fixing illicit discharges. So hopefully at this point you've gotten to the point where you have identified the presence of a discharge at an outfall and then traced it back to the source. So now comes potentially the really hard part, which is to remove or fix or correct that illicit discharge. There's 4 main questions to consider when we talk about removing and fixing illicit discharges. First, who is responsible to make the correction? What methods can be used to fix or remove the discharge? How long should it take? And how will the removal or correction be confirmed? And the answer to each one of these questions is really dependent on the source of the discharge. So, for example, when we talk about who is responsible for removing or fixing an illicit discharge, it really depends on the type of discharge. So in many cases, we see that if the problem is an internal plumbing connection, it's typically the responsibility of the property owner, be it a commercial property owner, an industrial property owner, or a residential property owner, to make that correction. It's often also the case with service lateral cross connections. So that's the case where the pipe is running from the building across private property to the storm drain or the sewer within the street. In that case, oftentimes that will also fall on the property owner, which can be a little bit challenging because these types of corrections and fixes can be more expensive and more complex because of the equipment and the excavation that might be required. A third common type of problem is associated with infrastructure failure within the sanitary sewer or within the MS4. In this case, it really should be the responsibility of the municipality or the MS4 owner to make that correction. And then finally, the last typical source, transitory discharge, can be very challenging. But in this case, it's usually the responsibility of the property owner or of the discharger to make that correction or do the cleanup necessary to fix the problem. The methods to fix illicit discharges really vary depending on the type and the location of the illicit discharge. Internal plumbing corrections can usually be performed using standard plumbing supplies for relatively little cost. For correction locations that occur outside of the building, like those lateral connections, costs tend to be significantly more expensive due to the specialized equipment. And we would really recommend that you consider developing a list of certified contractors that either the MS4 or the municipality uses to make those corrections, or that you can refer private property owners to make those corrections. The next question that we often get asked is how long should it take to make this correction? And again, this really varies depending on the type and location of the discharge. And again, as we discussed this a little bit earlier, this is really a point or decision that should be made during the development of your local ordinance. Generally, we found that if the illicit discharge is a significant health or environmental threat, it should be fixed or removed or discontinued immediately. When discharges are not a significant health or environmental threat, then after notification by a municipality, the property owner should have perhaps 7 days to stop discharging, or 30 days if this involves some type of repair of infrastructure or a pipe connection. Then finally, the last critical thing to remember is that we should not just assume that because correction has been made that the source of the discharge has been completely removed. So it's pretty critical to go back in and confirm the removal of that discharge. And this can be made both at the source, for using something like dye testing to confirm that the fixture is no longer connected to the storm sewer, or you can use some type of an inspection method like video inspection, sandbagging to try to collect the sample to ensure. But then also, it's not just a matter of checking just the property itself, but you should also check the adjacent area to ensure that there are no other sources of discharge within that particular section of the storm sewer trunk. So with that, I'll ask Dan to talk about a few more examples related to removal and correction.
My experience on the time to fix really varies, and I think is very similar to Jennifer's. When it's a municipal problem that we find, it's typically fixed very, very quickly. For example, we found a sanitary interceptor in one community that at a chamber running along the river, a bulkhead had failed. This was a significant interceptor, I think 18 or 24 inch in this medium-sized community that was discharging directly out to the river. When we brought that to the community's attention, the community maintenance crews had the problem fixed in less than 24 hours. Despite bad weather conditions, they went out and fixed it immediately. Another example was one that we found, again, a sanitary interceptor that in this case, 25 plus years ago, the chamber system had been constructed incorrectly, and rather than being diverted to a new pipe, or a 25-year-old pipe now, it had been diverted directly out to the creek. This problem again was fixed very quickly in relative terms. It was a matter of weeks. It was a very complicated system, and so to get in there and take care of it took a little bit longer. But again, when it's a municipal problem, it happens very quickly. We find that when you have the private connections to the municipal systems, the typical residential house lead as an example, it's a matter of writing some letters and maybe meeting on site and talking with the property owner. But typically those problems are corrected within a month. But like Jennifer said, I think some of the septic system ones commonly take a little bit longer to correct, I think in large part due to the expense. We've had some locations where we've had the median annual household income has been below poverty level, and when you go in and you try to fix the problem, the homeowners just honestly can't pay for it. They can't afford it. So those problems take a lot longer to fix, and those are just kind of my general observations over the years.
Great, thanks, Dan. Now we'll hear a case study about controlling illicit discharges from food service facilities. I'll turn it over to Ann Wilson. Again, Ann is the Superintendent of Environmental Services with the City of Alexandria in Louisiana. Ann?
Thank you. Thank you for the opportunity to speak to you today about the City of Alexandria's illicit discharge program. From the downtown area, we see that Alexandria is located on the Red River. My presentation today will include an overview of the city's demographics and the unique aspects of the city's illicit discharge program, which will include identifying the problems at the source rather than the introduction of pollutants into the receiving stream and stormwater systems. You'll see how we used existing food and drug laws to supplement our city's stormwater ordinance to prevent illicit discharges. And we also developed minimum standards for the construction of dumpster areas, which also aided in preventing discharges from the food service facilities. Alexandria is located in the center of our state, and all the cities shown on this slide are either Phase 1 or Phase 2 MS4 cities. Alexandria ranks 10th in population among Louisiana's major cities, with a population slightly over 46,000. But what this slide doesn't show is that Louisiana is a fairly wet state, and Alexandria has an annual rainfall of 61 inches. Rainfall is fairly evenly distributed throughout the year, with our wettest months being November through January. Our state is susceptible to large rain events associated with hurricanes and tropical storms, and in September of 2008, the rainfall in Alexandria associated with Hurricane Gustav measured over 20 inches in a 4-day period. The majority of the rain occurred after the storm had already passed, with a heavy rain cell producing over 9 inches of rain in a few hours on September the 4th. You can see by the photo that managing the storm MS4 program is a real challenge in these types of conditions. All states regulate food service facilities through food safety regulations. In addition to state regulations, the Food and Drug Administration has regulations concerning the proper disposal of sewage, runoff from dumpster areas, and cleaning operations conducted at these facilities. The link that I've given you on this slide will direct you to the codes for your state. It will also give you the name of the state agency responsible for enforcement. By partnering with your state agency and using these existing state laws as well as the federal laws, you have another tool in enforcing illicit discharges at food service facilities. The City of Alexandria wanted to incorporate these regulations into our own city ordinance. We understood that new construction of commercial facilities that require cleaning at dumpster areas or from the food service facilities have two options. They can either discharge directly into the MS4 if they get a valid NPDES permit from the Department of Environmental Quality, or they may choose to discharge to the sanitary sewer system. But they have to keep in mind that we do not allow stormwater into the sanitary sewer, and they also must meet local discharge limits. The city developed a standard design for the dumpster area to aid our developers in contractors in understanding how to prevent illicit discharges from these areas. On the resource button, you have our standard design of our dumpster area. And by following this design, you can see that our dumpster areas are enclosed, they're covered and curbed to contain the discharges that occur around the dumpster. That could be leakage from the dumpster as well as cleaning operations. And these discharges are routed to the sanitary sewer, and they're treated by the grease trap before they enter the sewer system. The covered area and also the berming around the bottom of the enclosed structures prevent the discharge of rainwater into that open drain. We realize that blowing rainstorms can have a little bit of water that enters underneath that covered area, but that's minimal when you consider an open drain in the parking lot would flood our sanitary sewer system with rainwater. So before we began a program of inspecting the dumpster areas of our food service facilities, the city wanted to notify the owners and operators of these facilities of our intentions. The city notified all the users by mailing them a packet of information which contained the purpose of the program, explanation of potential sources of pollution, the BMP's best management practices that they could use. We also included our inspection form, which again is at your resource button on your console, and the criteria for the evaluation. This program enabled the city to meet the requirement of the Illicit Discharge and Detection Program by providing education to our businesses about the hazards associated with the improper disposal of waste. We covered key areas of the BMPs, including maintaining their dumpster and compactor areas. We gave them guidance about minimizing the amount of liquid waste discarded in these areas, keeping the dumpster lids closed at all times. This is especially important for those older facilities whose dumpster areas were not covered. We instructed the kitchen help and also the management of our food service facilities to inspect the areas regularly and take corrective action when needed. By giving them guidance on cleaning and washing of areas, the use of sweeping and the use of blowers rather than washing material to the storm drain, we're able to eliminate and prevent discharges to the storm drain system. We also gave them guidance about designating a cleaning area outside for floor mats and trash cans if they did not have an area inside their facility, and also talk to them about connecting that to the grease trap, having it covered, and discharging to the storm drain system and discharging to the sanitary sewer. We encourage them not to have a storm drain, discharge to the storm drain. By encouraging facilities to develop spill control plans, facilities became proactive rather than reactive. The inspection form that the city uses has very specific questions in key areas that we evaluate. The waste grease container tends to be a major area of concern, which also tends to have discharges to the storm drain system. What we do on our inspection is to look to see if there's container. Most likely it's going to be found at the rear of the building, at the rear of the parking lot. And the picture that we see stained concrete, so we know that they've had spillage over time. So that information was recorded on our inspection form. We will rate the spillage as being either minor or major. Also, the 5-gallon pails around the waste grease container were not properly disposed of by the restaurant. They had grease in the container, and so during rain events, these containers can fill up with water, and we can have an illicit discharge to the storm drain system. We also note on the inspection form if any grease is entering the storm drain. Another area of concern is the dumpster area. The city's ordinance requires this area to be enclosed. Upon closer examination, we see that the dumpster lid is not closed, so during rain, water will fill the dumpster, and it will either leak out or be discharged when the solid waste company empties the dumpster. The Department of Health and Hospitals, our state agency, requires hot and cold water to be at the dumpster area for cleaning purposes, but the city of Alexandria, we're interested in where is that wastewater going. We also look inside the dumpster area to determine if liquid waste or leaking garbage bags can contribute to the problem. We see in the photo that we actually have a discharge leaving the dumpster area, moving forward and to the left of the slide. So we're noting that discharge on our inspection form. Some facilities will use materials to clean up spills such as oil dry or absorbent pads. And we're looking to see, is this material ever picked up, and if they can clean this area and not have a discharge to the storm drain system. Closer examination of this area shows in photo 1 that there was actually open containers of grease and fats stored next to the dumpster, probably waiting to be poured into the waste grease container. But as rain events occur in Louisiana at a moment's notice, these could easily fill up with water and discharge to the storm drain. We also see that the dumpster had no lid at all in this case, and so this area could not be covered to prevent illicit discharges. Equipment cleaning area should be done inside the restaurant, and too often I see that they bring floor mats and trash cans and other equipment outside for cleaning, and often that wastewater discharges to a street, gutter, or storm drain grassy area around the restaurant. So again, we give guidance that this should go to the sanitary sewer for treatment at our POTW. Surface areas are also an area of concern. Restaurants have large areas of concrete for parking for their constituents, for their customers. We see litter, debris, sometimes oil and grease found in this area. We encourage the restaurant to sweep and use blowers rather than wash this material down to the storm drain. We're also looking at evidence of soap or other pollutants being discharged. This actually occurred at one of our restaurants. When I was there doing an inspection, I saw this 30-gallon trash can next to the storm drain, and they already had soap inside the storm drain when I arrived at the facility. When I was in the parking lot taking other photos, an employee of the restaurant dumped the contents down the storm drain. So the kitchen staff and the restaurant manager got a Illicit Discharge 101 lecture from Ann at that facility. We will give an overall housekeeping rating to the facility. We can see again the pails stored next to the dumpster. The heavily stained concrete shows that they've had spillage and leakage. The areas that we give the overall rating to are, again, the ones we looked at previously, the dumpster area, outside waste grease container, and equipment cleaning area. This facility received an overall rating of poor. And what occurs is we use a carbonless multi-copy form, so we're able to leave the inspection form with the manager. And we're also can bring a copy back to my office along with the photos. The city writes a detailed report to the restaurant owner, and the restaurant's given 10 days to take corrective action. Note those corrective actions in writing back to the city. Both the initial inspection and follow-up inspections are done unannounced at our food service facilities. So let's look at a follow-up inspection at this restaurant. We remember that the dumpster area had an illicit discharge to the storm drain and had the 5-gallon pails of grease stored next to an open dumpster. On our return several weeks later, we see no discharge, and we'll have some additional slides on what did it look like inside that dumpster area. We looked at the waste grease container. The spillage had been cleaned up. They no longer store the empty 5-gallon pails next to the dumpster. I didn't mention, but when we did our initial inspection, we actually saw some food products as well as some grease in the grassy area noted by the arrow in the after slide. This had been cleaned up. Our follow-up inspection looked over the grassy area as well as the parking lot of this facility, and we saw no illegal dumping or discharge of this type material. Closer examination of the dumpster area, we found that the dumpster with no lid had been replaced by a new dumpster. There was no storage of 5-gallon pails of grease or oil next to the dumpster, and the dumpster lid was closed. This is my contact information, so if after the webcast, if you have additional questions or concerns, or information you'd like about the City of Alexandria's program, feel free to contact me.
Great. Thanks a lot, Ann.
Okay.
We do have a number of questions, so we'll take the remaining about 15 minutes and hear some of the questions and responses. Ann, since you just presented, we do have a question for you from James, who asks how large your employee group is dedicated to these IDDE inspections and investigations.
Well, we have several departments in the City of Alexandria. The inspections of the food service facilities are handled by our pretreatment department, which is in the Environmental Services Department for the City of Alexandria. So I have myself and 3 other inspectors. And so when we're doing pretreatment inspections and monitoring compliance to the sanitary sewer system, we saw that these other discharges were occurring to our storm drain system. So we just utilized a program where we're already out there taking samples and doing inspections and just expanded our scope to be outside the building instead of just concentrating inside. We also have a code enforcement division which has 6 inspectors, and they do inspections of illicit discharges, take complaints from our hotline, and also do inspections at construction sites. So we tend to multitask in our city and follow up and cross over and do not only stormwater but also pretreatment inspections as well.
Great. And a follow-up question, and while I read this off, I'm going to push out the website for EPA's IDDE resources. Restaurants typically have a high turnover. How do you handle this, and do you see some of the same violations as you go back and do repeat inspections at the same facility?
Well, the city has a database of all of our restaurants through our pretreatment program, and so I know when people change management there. They also fill out paperwork every 2 years to give us contact information, and then they're also getting guidance from us with the information packets that we send. I guess because we're there out in the field so much, we can tell when management has changed or kitchen help because we notice some differences in how the area is kept, and then we'll concentrate on that particular restaurant. I think we have about 128 food service facilities in Alexandria. So we're a somewhat smaller city as compared to the challenges a very large city would have.
Okay. Great. Before I read the next question, I just wanted to note that we have an estimated attendance of almost 1,800 people, so we thank everyone for joining us today. Jennifer, the next question is from Wesley, who asks, do you have a sample ordinance or policy that municipalities can use?
We do have a sample ordinance. There is a sample ordinance within the Illicit Discharge Manual. This is a kind of a national guidance again, but it's one of the appendices within the Illicit Discharge Manual, and it can be downloaded from the website, USEPA's website, with illicit discharge resources. In addition, also, I know several states have put out very state-specific local illicit discharge model ordinances. I know the state of Ohio has one, for instance. I would encourage you to check your local state to see if they do have a specific local ordinance.
Great. Christopher asked, and I'll just throw this open to Bryan or anyone, how should you handle charity or fundraising car wash operations? This can get very political.
All right. Yes, that's a touchy situation. Again, it gets to the education end, and there are brochures out there that can be downloaded for free where it describes to residents what you do about car washing. Basically, you want to tell them that you want to try to keep the wash waters out of the storm drain. So that means you try to do it on a large grassy area where it could be kept and maybe just infiltrate. Or you can rent these portable systems that will capture water, so you can either put it into the sanitary drain or or into a truck or something for disposal in some other way. So that's the best way to handle it, is education and just simply trying to keep it out of the storm drain.
And of course, if you're going to put it in the sanitary sewer, you have to get advance permission from the POTW for that. And there are a number of cities that have bought these sump pumps and basically rent them to charity car washes or give them out for free to use for them. Next question, Dan. We have a number of questions about Sable, and people were asking like what kind of dog he was or what type of training the dog received in order to be an illicit discharge dog.
Well, the breed of the dog, actually Sable is a mutt. We don't really know for sure what kind of dog he is. We suspect he has some shepherd in him as well as maybe some greyhound.
He's a rescue dog, right?
He's a rescue dog, yes. Rescued him from a shelter in the local area. So the type of dog isn't necessarily so important. It's more the traits that you look for that drive to find things and want to. It's more of a trait issue. With having said that, it's some of the working breed dogs work better than others. The training for the dog, the individual who trained Sable came from law enforcement, over 10 years of experience in both search and rescue and in training dogs with law enforcement for evidence recovery, et cetera. So there was a very specialized training for canine scent tracking. There is no book that I'm aware of for training your dog to find human sewage, although maybe there should be. So it's more of a case by case. You need to find somebody who has that scent training capabilities, and like I said, the search and rescue folks or the law enforcement are typically the areas that you'll find that skill set.
Great. And we have a question from Jessica who asks how often you inspect your restaurants, and can you also mention the size of the population of the city of Alexandria?
The population is a little over 46,000, and we just inspect them ongoing, throughout the year. I would say we try to get to all of them within a 2-year period, but when we're out doing our pre-treatment inspection, and restaurants are usually concentrated on certain streets in the city, we'll just go from one to the other. Because once you start looking at one restaurant and sending them a report and citing them, then they won't do anything but call you and tell you that the restaurant next door to them doesn't look any better. So you have to be prepared to do a blitz and hit the majority of the restaurants in a very short period of time because the finger pointing starts. So and we probably have about 6 or 8 users per minute through our pre-treatment program, so we're sampling them on their discharges to the sanitary sewer each and every month. So we're in the areas known to have restaurants every week sampling and taking wastewater samples from their discharges to the sanitary sewer. So seeing the illicit discharges or problems in the storm drain area, we're behind the restaurant at cleanouts and sampling stations already, so it's very easy to stop and conduct an inspection and take a few pictures and notify them of any deficiencies by administering both programs together in my department.
Okay, Bryan, next question is from Jack, who asks about road salt contamination of urban streams, which made news in Michigan a few weeks ago. In urban areas, you use seasonal meltwater runoff from the roadways and parking areas. They're typically handled by the stormwater conveyance system. Is this meltwater runoff going to be regulated by EPA as it applies to road salt usage?
Well, basically, snow melt is already regulated. It's regulated as stormwater. So if it's in an MS4 or a permitted MS4, then it is regulated because you can't discharge road salt meltwater without some kind of treatment. Supposed to not do that. So it's the same as any other kind of stormwater. Knowing that it will have solvent, it should be routed through some stormwater control measure, otherwise known as a BMP, before it's discharged. So basically that's it. And certainly salt piles cannot be exposed to the elements either. It's mandatory that they be covered. So we're trying to get it before it becomes in the runoff, and when it's already in the snow, it has to be treated from then on.
Sorry, I was on mute there. If you need it to print out the participant certificate, the URL is there, and we will now answer a couple of additional questions. The next question asks if you need permits for introducing dyes into the storm sewer system. And I'll ask that to either Jennifer or Dan.
Well, when I was talking about using dyes for illicit discharge tracking, I was referring to non-toxic dyes. And there's a variety of non-toxic dyes in the market made specifically for this purpose. So since they are non-toxic, generally, no, you should not need permits. However, I will say that I don't know the rules and regulations of every state in the country, so you should confirm with your state environmental agency if you do need any kind of permits. The other thing I wanted to note is that before you do dye testing, you should also be sure to notify any other local agencies that may have some spill response responsibilities, like the fire department, so that they are aware that this dye testing is happening, when it is happening, and where you're doing that.
I'd just like to echo that. Do check with your local officials, both the municipality and the state. I know the state of Michigan does require permits for dye, and they have a list of approved dyes that can be used. But anytime there's a potential of releasing a dye to the receiving stream, they require a permit to be in place.
Great. Thanks, Dan. And we had a question about how restaurants are supposed to clean up the grease stains, for example, around the dumpsters and that. Do you have a method you've seen works well or a recommended method for doing that?
Well, if they don't have that area curbed and contained and covered where it goes into the grease trap and then to the sanitary sewer, of course you have more leniency of how much water you generate, and you know that it's going to be pre-treated. But if it's one of those existing restaurants where it's not connected to the sanitary sewer, then I advise them that they need to cover that storm drain and not allow that discharge to go there. And when they're washing and cleaning, to have a wet vac out there and pick up the wastewater, and then they'll be able to bring it inside their restaurant. Usually there's a mop sink. They can discharge it inside there, and then it will go to the sanitary sewer. You may also be able to use some types of absorbent pads that are made specifically to capture hydrocarbons, oils, and greases, and then let the water, go to the storm drain. So there are different areas that they can look at in order to remove those pollutants, remove the pollutant with the wastewater, or, be connected to the sanitary sewer, but have that area covered so we're not inundated with stormwater into our sewer systems.
Okay, thank you. Let's see, I just got a note that I think our certificate link might be bad. We have had some problems uploading documents to the EPA website, so we will post the certificate to that URL in the next day or so as soon as we're able to. So just keep that link, and the certificate will be posted there. If not tomorrow, then the next day. We do have time for one more question. I am going to push out the evaluation survey here. We do appreciate your feedback. Please fill out the survey. It'll appear in your slide window there. You need to click on the Enlarge Slides button to view and complete this survey. But first, I'd like to remind you that this webcast will be archived after today's presentation. It should be available in a few weeks, and it will be available on EPA's MPDS training website. Don't forget to download the certificate, and again, If you have any trouble with it, we will post it on that link in the next day or two where you can download it and fill out everybody's name. One additional question for Bryan or Ann, how do you handle plant cuttings or landscape waste into the MS4? Is that considered an illicit discharge?
Well, in Alexandria, you actually get a citation if you blow grass clippings into the street. So we're pretty stringent on if you're out there doing yard work that once you finish that you need to be picking up those clippings and bagging it or, composting it or doing something other than blowing it into the storm drain or the city street that'll eventually end up in our storm drain system.
And that's really impressive. Of course, if you don't know, that's grass clippings and stuff will shoot your BOD or nutrients in your streams through the roof, and it's just not good.
Right. When I see citizens and they point out that they've gotten citations, and that's through our code enforcement with those 6 inspectors, it gets their attention. I think it's a $25 ticket that our citizens will get if we see grass clippings, and that's either or the homeowner gets it, and if they hire a lawn service and their lawn service did it, the homeowner is the one who gets the ticket.
Great. Well, we've run out of time, so I'd like to conclude today's webcast. I'd like to thank Bryan, Jennifer, Dan, and Ann for presenting today, and of course, thanks to everyone who joined us. This ends today's webcast. Thanks for joining us.